देखें डॉक्टर रियाज अख्तर है, मुझे तो नहीं लग रहा। पूछो क्या मसला हुआ है। आ गया ठीक है। जी, फॉर्मली अनाउंसमेंट स्टार्ट करने से पहले मैं सबसे दरखास्त करूंगा कि आप प्लीज अपने वेब कैम ऑन कर लें, और ये ड्यूरिंग द लेक्चर जिन लोगों ने रजिस्ट्रेशन कराई हुई है वो प्लीज अपने वेब कैम्स उन्होंने ऑन रखने हैं। आपने स्क्रीन पे लाइव अपीयर होना है। दोबारा रिपीट कर रहा हूँ, अपने वेब कैम जिन्होंने ऑन नहीं किए और जिन्होंने सीपीडी की रजिस्ट्रेशन कराई हुई है वो काइंडली अपने वेब कैम ऑन कर लें, और अपने जो माइक्रोफोन की पोजीशन है उसको म्यूट पे करते हैं थ्रू आउट द लेक्चर। दो बज के 4 मिनट हुए हैं। नॉर्मली हम 2:05 या 2:10 पे शुरू करते हैं, लेकिन पार्टिसिपेंट्स हमारे पास काफी आ गए हैं तो मैं 1-2 मिनट में इंशाल्लाह शुरू करूंगा। अभी पार्टिसिपेंट्स आ रहे हैं यहाँ पे, जैसे ज्वाइन सबकी ज्वाइनिंग हो जाती है, थोड़ा सा टाइम लगता है ज्वाइनिंग में, ही ज्वाइनिंग हो जाए तो फिर मैं फॉर्मली जी शुरू करूंगा। जी, दो दो साहेब हैं जिन्होंने अपना वेब कैम ऑन नहीं किया, काइंडली वेब कैम ऑन कर लें, फिर मुझे बार बार अनाउंसमेंट करनी पड़ती है। बल्कि तीन तीन हजरात हैं, वलीद फराज साहब, उमर अवैस साहब और फरहान नवाज साहब, अपना वेब कैम ऑन कर लें। ठीक है, उमर अवैस ने हो गया। फरहान नवाज साहब, आपको मैं फिर रिमाइंड करा रहा हूं, आपने अपना वेब कैम ऑन करना है। फरहान नवाज को फोन करके बताएं कि उन्होंने वेब कैम ऑन कर दिया। कर लीजिए। नहीं किया। लेकिन आप चेक करें, स्क्रीन पे आप नहीं आ रहे। Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and good afternoon to all the participants and greeting to those who are watching us live on Facebook. Today, PSCE is presenting its technical lecture number 40. Topic is rock blasting techniques, case study, RESHUN hydropower tunnel. Our guest speaker today is Dr. Riaz Akhtar. Before the introduction of the speaker, as usual, the rules of this webinar will be spelled out. First, registered participants for CPD points have to appear live on webcam. Only exception is for the ladies. If they wish, they can cover their face. But they have to appear live on webcam. The microphones of all the participants, except that of the speaker, shall remain in the mute position. At the end of the session, there will be a 20-minute question-answer session. There you can ask the questions freely and through your microphone. Our participants on Facebook, they have to ask the questions through typing the text only in the chat box. And I will read their questions on the microphone on their behalf. The participants who are on Zoom during the lecture, if they have questions, they can also type their questions on the in the chat box. And if the questions are pertinent, I will ask them during the lecture. Otherwise, it would be, I will read them during the question answer session. Kindly, all participants, I will again request they should keep their microphone in mute position. Please keep your microphones in mute position. Thank you. Now the introduction of the speaker. Today's speaker, as I have informed you, is Dr. Riaz Akhtar. Dr. Saab did his BSc in Civil Engineering in 1980 from UET Lahore. Then he did his, I would request again, please mute your microphones. Kindly mute your microphones. Some background noise is coming. Kindly mute your microphones. Thank you. Dr. Saab did his bachelor's in civil engineering in 1980 from UET Lahore. Then in 2001, he did his master's in water resources and irrigation engineering from UET Texas. Then again, he did his master's in transportation engineering in 2005, again from UET Texas. He did his PhD in transportation engineering in the year 2012 in I'm sorry, he did his PhD in water resources and irrigation in 2012 from UET Texas. He started his career as a junior engineer in Builder Associates, where he served from 1980 to 1981. In the same year, 1981, he joined C&W department, which is Communication and Works, Punjab, from where he retired in 2014 as director P&D. During his career in C&W, he has worked on fast-track mega projects related to highway, rigid and flexible pavements. He also served in the department for the building projects. There is again some background noise. Now, I really don't know how I should make the announcement that people should understand that they have to keep their microphones in mute position while the lecture is going on or while I'm introducing the speaker. Kindly have some compassion on me and please keep your microphones in mute position. You see, because of the interruption, either me or the speaker, he gets disturbed and the flow is also disturbed. I will repeat his employment again. Dr. Saab started his career as a junior engineer in Builders Associates, where he served from 1980 to 1981. In the year 1981, he joined Communication and Works Department, Punjab, from where he retired in 2014 as Director P&D. And during his career in C&W, he has worked on highway projects, building projects, and especially the building projects, highway projects in the hilly terrain where treatment, rehabilitation of landslides and slopes stabilization was needed. And Dr. Saab has also worked on RESHUN hydropower project during his career. He was deeply involved in this project. He acquired extensive experience in the tunneling work. In fact, he played a pivotal role in the construction of this project involving a complex and challenging penstock tunnel for the hydropower station in a far-flung area of RESHUN near Chitral. Now, this is the project which he is going to discuss in his lecture. Currently, Dr. Riaz Akhtar is associated with Department of Civil Engineering of Leeds University, Lahore, as Professor of Civil Engineering. His affiliations are with Pakistan Engineering Council. He's a fellow IEP Pakistan, and he's also a founder member of Pakistan Society of Civil Engineers. Research publications. He is an author of 8 research papers which have been published in reputed journals. Now, this was a very brief introduction of Dr. Saab. Now, before I hand over the floor to Dr. Saab, I would again request, please keep your microphones in a mute position and please appear live on the webcam. Thank you very much. Dr. Saab, the floor is yours. Please go ahead.
Well, am I audible? Screen is clear? Hello?
Dr. Saab, you are very much audible. The share screen is also working. Please go ahead.
Thank you, Tahir Sultan, for your kind words and introduction in a detailed manner. Ladies and gentlemen, welcome you all. And I'm thank you US for sparing your precious time for this lecture. Let's start then. Yes, the title is Rock Blasting Techniques and Case Study of RESHUN Hydro Power Tunnel. There are 2 parts of this presentation. Part A is rock blasting, and the part 2 is case study of RESHUN hydropower tunnel. Rock blasting techniques. Rock blasting, 2 materials are involved. One is rock, and second is explosive. The services of these 2 materials are for humanity are great. And they provided so much solution for so much engineering problems, both these 2 materials. Yes, rock. Rock is an aggregate, you all know, of minerals which are naturally occurring substances having a fixed chemical composition. Thus, minerals control such much of the rock behavior. The quality of rock is then depending upon the mineral that rock is containing that mineral. Sometimes minerals are strong, then the rock is hard rock. If the minerals are weak and soft, then the rock is soft rock. I mean, very generalized classification of the rock. I'm not going in a detailed geological classification of the rock, and it's a general classification of the rock. Rock and rock mass. What is the difference between rock and rock mass? Rock means continuous, homogeneous, isotopic, intact rock and containing no significant fracture there. Whereas rock mass is the rock with joints, fracture, with faults, with all geological discontinuities in the rock matrix. That is a rock mass then. Actually, in tunneling and in engineering, we are dealing with the rock mass, not the rock. So just I clarify these the terminology of the rock and the rock mass. What is rock and what is rock mass? What does it mean when we are calling rock mass? That is the rock mass, the rock with all faults, joints, fractures, cracks we are dealing with. Type of rocks formed by three main origin. Again, it's a simplest classification and division of the rock. Simplified, three main origins are there. Igneous rock from magma, lava, volcanoes. Sedimentary rock from sediments, lithification with the time, and metamorphic rock through metamorphism due to high pressure and temperature. Sedimentary rock from sediments, lithification. With the time, the water in the substance in the rock material getting reaction with the ions of the rock, and then a solidified, well cemented rock particles, sediments are appeared on the 75% of the surface of the earth is of this sedimentary rock, whereas in the crust the sedimentary rock is only about 5%. I'm explaining this because the case study of the tunnel which we are going to discuss now today is was the 75% of this material. Well cemented conglomerate was there for the blasting purposes. So I explaining it a bit in a detail, that sedimentary rock there. Now we come to define the explosive. An explosive is a reactive substance that contains a great amount of potential energy that can produce an explosion if released suddenly, usually accompanied by production of, there is a light, heat, sound, and pressure. When this explosive react there, these are the parameters we are observing there. And while we are talking about the explosive, no one can ignore that great man, Alfred Nobel, Swedish chemist, engineer, inventor, businessman, philanthropist. The great man invented the first generation dynamite in 1867. He is also known for benefactor of Nobel Prize. And I mean, this is the highest prize of the world, I think, so far now. In Pakistan, main manufacturers of explosive are Biof. One is Biof, and the other is Nobel. Biof in Akhtar, they are manufacturing super blaster, breaker. Their product is a bit inferior as compared to the Nobel.
Dr. Riaz,
Ji, please.
Can you maximize your screen, please?
Yes, is it okay now?
I think so. It is now at my end. Looks to me. No, yeah, now better. Now better. Yeah, carry on, please. Now it's okay.
Okay, thank you, dear. The famous Nobel is a joint venture with Sweden, with Japan, with many other countries. They are producing a quality explosive, quality dynamite there. Now they are having a joint venture with Saudi Arabia and other countries also. Commercial explosive of Nobel, nitroglycerin-based dynamites, S3 seismic explosive, Webox. Webox is an excellent product of Nobel. Webophyte, and then the powder explosive, Webonite and N4. Ammonium nitrate with fuel oil, that is N4. Then emulsion explosive, seismic emolite E3, emolite 150, and then emolite 100. permissible emulate. These are the emulsion explosive there. I mean, to detonate these explosives, there are accessories, detonators. Detonator number 8, plain, that is a trade name, and electric delay detonator number 8 also. Different delay is there. I mean, that is 25 milli detonator, then half-second detonator. This is a delay time. 25 milli means it is 1/40th of the second. Time delay is 1/40th of the second. There is a Leher, this is also trade name of the detonator, seismic detonators, millisecond, MS, and a half-second electric detonators. Blasting wood, Webo cord is there, safety fuse is there. And then the Webo's, brief introduction of the Webo's, nitroglycerin-based dynamite. This is excellent product of the Noble and giving the excellent result of the advanced there, charging there. It is very good in handling, and the safety record is beautiful, no risk is there. I mean, it's a beautiful product of the Webex. State-of-the-art type of product is there, and widely used in explosives, in tunneling, in all other activities of excavation on surface or underground excavation. This product is excellent, and mostly the engineers are using this Webox here. Then there is a seismic explosive S3. It is mostly used for the exploration of oil industry. They are using it. Good for water resistance. It is extremely high hydrostatic pressure bearing, capable of withstanding that. So it is being used for oil exploration. This is a good product for that field. Webonite, it is a bit inferior nitroglycerin-based dynamite than Webox. It is a bit cheaper also. I mean, the combination of these two explosives, Webox and Webonite, are good to get a optimum advance in excavation, in tunneling. So this product is also very good and good in combination to achieve some economy of the blasting. And it's good for the soft rock, but the combination of Webox and Webophyte can give good result even in the case of hard rock. Webonite is a low density explosive, powder explosive, suitable mainly for column charges. Sometimes we charge the column, and primer we use as a dynamite. Webox we are using as a primer dynamite, and then with the combination of Webonite and Webophyte, we get the economy there. Then this is N4 again for the large explosion and for the large diameter drilling hole. And for the dry condition, we are using this N4 for the excavation of the surface, preferably surface blasting, benching. We are using this N4. Seismic emulite, seismic emulsion explosive E3 meet the highest standard of safety. E3 has excellent storage properties, especially of to bear the temperature and humidity. It is good for the high temperature and the humid places there. Emulite 150, again, this is trade name, trade nomenclature of the explosive. It can be used as bottom charge for any kind of blasting, especially for deep underwater blasting. We are these emulsion explosives we are using there. Then these are also emulsion explosive of different trade nomenclature, having a different properties. For specifically for specific job, we are using this emulsion explosives. Then there is a detonators to detonate the explosive. These are the accessories of Noble again. Plain detonator. This is a no electric delay there. When there is no, we are having an open excavation. Open. That's a bench excavation. So we are using this. And at that time, we are not needing any delay blasting there. In case of bench blasting or surface blasting, we are always having two faces free there. So the rock can move easily. But in case of underground blasting, rather tunneling, we are having only one face for moving. Space is there only at one face. But sometime in bench blasting, we might be having a three-phase even, if it is a corner blasting there. So we encountered three-phase open we are having there. And that is very easy. With a minimum use of the dynamite, we can get a maximum production there. Then there is electric detonators. These detonators are required for blasting purposes, especially for tunnel or generally underground blasting. We are requiring the delay to blast the different drill holes. This is a blast design. We compel to have a different circle. So to, having a blast as we desired there. These are again detonators. Leher is again commercial nomenclature of detonation. This is initiated by shock wave, not electric detonation is there, but Leher is acting as a non-electrical detonator and acting as with the shock waves. Advantage is no stray current is passing anywhere in case of Leher. No side initiation, no noise problem, simple and rotational rational connections, no limits on the size of the blast round. You can blast as many as drill hole as you like. Excellent detonator. Seismic detonators used for the exploration of the oil field, creating a sensitive seismic explosive to detonate. This is very, these two are very important detonators. Millisecond, half-second electric delay detonators. We select these. Millisecond means it is a 1,000 second of the second, 1,000 part of the second. And we used 25 millisecond in our RESHUN tunnel. That meant 1/40th part of the second, 1/40th part of the second. Millisecond and half-second electric delay detonators are meant to effect delayed blasting action in multi-row bench blasting and tunneling, give better fragmentation of the rock. As desired, as we can have desired to fragmentation of the rock, we can have a required size of the excavated rock there by just changing the timing and just changing the quantity of the dynamite. Then there are Weber cord, detonating cord is there, that is waterproof with a PVC and having a coating of powder explosive there. We are using that also. And this is a famous black safety fuse. As we have observed in the movies, they are blasting with this, a cord is burning there and reaching to the dynamite, and then there is a blast. That is the famous cord there we are using there, this cord. Rock drilling system. Mechanical operation can be performed basically in only two ways, by percussive and the rotary action. Though two actions are there for the drilling purposes, we are using only these two actions there. And sometimes it is a combination of these two actions, drilling and percussive motion of the drill machine. That is then called it hybrid method, and rotatory percussive method is combination of these two actions, mechanical actions for the rock drilling. Techniques of controlled blasting means to mitigate adverse impact of blasting in open pits, quarries and tunnels, underground metal mines, and construction working. The purpose is, the technique is we to do the blasting in this way that the minimum disturbance should be there. disturbance of the inhabitants, disturbance of the other, locality there, structure there, and disturbance of the mother rock even. We are requiring not to damage the mother rock even. So that is a technique to control the blasting there, to save all these, to mitigate all these problems there. In both the mining and the construction industries, blasting, the predominant method of for fragmentation of consolidated minerals, deposit and rocks. This is the method for getting the fragmentation of the rock or minerals. Controlled blasting methods are used to control adverse impacts, such as we have to control the overbreak, and the ground vibration, noise, air blast reduction, fragmentation, tear away pressure, fly rocks. These are the blasting problems. We have to check these problems there and to mitigate these problems. That is the controlled blasting. To control these all impact of blasting there. Following are the techniques of controlled blasting: line drilling, one method; trimming, cushion blasting, second method; and then smooth contour or perimeter blasting, pre-splitting. These are the techniques, blasting techniques we are adopting to mitigate all those problems of the blasting. The system, line drilling. What is line drilling? The system involves a single row of closely spaced, uncharged holes along with the neat excavation line. We drill a line of the drill holes without charging them, just providing a sliding surface, breaking surface to save the mother rock behind that line drilling, behind that line. We don't want to disturb the mother rock, so we drill some holes in a line to split those portion of rock mass, which we are going to blast that, which we are going to fragmentate. We provide a line there. This provides plan of weakness to which the blast can break. It also reflects the shock wave generated by blast and help to reduce shattering and stressing in the finished wall of the host rock. The holes are drilled along the excavation line. This is one method. And then the pros and cons of line drilling. This technique gives maximum protection to preserve its original strength. The disadvantage of this system is highly drilling quantities required, and drilling is an expensive exercise, expensive activity, costing it. So in this way, that is a disadvantage of this, but we are getting very smooth surface by adopting this technique after the blast. Trim blasting, like line drilling, trim or cushion blasting involves a row of holes along the specified final excavation. So, these holes we are going to charge that, whereas the drilling line, we were not charging those holes, but here we are using explosive and to get the same result there. As compared to line drilling techniques, trim cushion blasting is simpler and economical as increased spacing. Here in the drill line drilling, the spacing of the drill is very close, but here in this trim line and cushion blasting, the space between two drill holes is considerably spacious and having a wide space between two drill holes. Again, pros and cons. As compared to line drilling technique, trim or cushion blasting is simpler and economical as increased hole spacing are used. Smooth contour blasting. that is the technique for before doing anything, you drill the contour end line of your face. For example, if you are going to excavate the tunnel, the outer contour you have to give some cracking to that, and you do this contour blasting at the periphery of the tunnel. Different thickness of the hole and spacing is mentioned here. And for promoting safety and economy in underground excavation, working performance of blast is heading and to stop become very important factor. An ideal blast results in minimum of damage to rock with minimum of overbreak. Using this technique by contour blasting, we are having a minimum overbreak, because we give the initial crack already to the face there. Smooth wall, minimum fracture, minimum overbreak, less support required, better economy and safety in this technique we are achieving. This is the pattern how we are smooth contour blasting. This is the outer, this one. You see, this is the outer line of holes we are having for the contour blasting. We give the pre-cracking to the surface there to get the smooth wall here. So it is always helpful. Light charging is there. With the gap, you have a light explosive charges. Then this is the buffer zone, and this is the production hole. We are charging it in full length. This is the production hole. These holes are actually giving the advance to the tunnel. These are helping to give the surface smooth surface and to control the overbreaking. If we are having the same hole here as production hole, and we will get there are chances that we will get overbreaking of this tunnel face there. So I think I clear this. Then there is a technique of pre-splitting there. That is a popular technique also, that we provide a pre-splitting is there. We split the rock mass from the parent rock, from the back wall, and then we get the smooth blasting there, blasting pattern. Pre-splitting helps in isolating the blast area from the remaining rock mass. So this technique is very successful. We provide a face there by using this technique of pre-splitting. We split the required blasting rock mass from the parent rock, and we get the very smooth surface by providing the pre-splitting face there. Same again, the procedure is same. We are providing the hole along the mother rock, along the contour line, along the area we are requiring to blast there, and we split the blasted rock mass from the parent rock. Explosive then production blast, and prior to the main blast, we also have a pre-blasting of this pre-split line before the main blast is there. So we provide a pre-splitting cracking there of the extreme line of our face. This is an effective way of restricting back overbreaking, ground vibration, and we can avoid excessive ground vibration by adopting this technique there. In large open pit quarry blasting, some of the shock waves from subsequent main are reflected at the pre-split plane even. This is the pre-splitting of the rock there. Pre-splitting holes are there, lightly charge there, and we are having a blast before that. Before this main excavation exercise is there, we have preliminary blast in these pre-splitting holes to get fractured and then to save the mother rock here. Mother rock here. Muffle blasting. You know, while we are blasting there is a fear of flying rocks, especially if we are working in a congested area. This is a big problem to be checked there. When conducting in the six dense human habitation is there, congestion area is there, muffling blasting is a technique to avoid the fly rocks. We are covering the whole face with some mat, with some sandbags, with anything, old tires. You may use the old tire, and the muffle blasting is required in the built-up area where there is a fear that some fly rocks will damage the neighborhood there. I mean, this is the flying rocks of showing how they are flying away from the. If this blast is in the built-up area or congested area, we have to put some this sort of mat there to provide the to avoid this flying rocks to damage anything nearby. We may use also sandbag also to avoid the flying rocks there. This is a technique we are using there for yes, that was the brief introduction of the blasting techniques and the explosive and the detonation. Now we proceed to the case study of our RESHUN hydropower tunnel. This is a general generation of energy worldwide. What is happening? I mean, maximum this 26% is the renewable energy. That is hydropower, solar, wind, all these renewable energies is a good component of the total. And then the coal, energy with coal, yes, this is 38%, then oil 3%, gases 23%, and nuclear is 10%. This is an overview of the world energy production, how we are, where the hydropower stand there. Then this is a regional data. India was not there in this graph, but I got it from net that India is producing this hydropower 4,500 megawatt, whereas China 8,500, and Brazil and Pakistan is producing 2,500 hydropower energy there. Turkey is there, then one more country is Brazil, I think. Anyhow, this graph shows how the trend is going there. We are developing our resources of hydropower energy. Number of projects are under construction in the northern area, in other part of the country, and hopefully in the next decade we will be having a considerable contribution of the hydropower in our system. This is the reason that tunneling construction is going to be important as far as the hydropower is concerned, and as far as the transportation and other utility services are concerned. Now trend is to go for tunneling, and the result of the tunnelings are excellent. They are national highway has 25 kilometer tunneling in our country. Beautiful tunnels they have constructed it, and the trend has been changed now. instead of disturbing the toe of mountains and disturbing the environment adversely, they are going for tunneling now without disturbing the toe of the mountains. This tunneling is safe even, and also economical as compared to the bridging. So the many tunnels are now under construction. So this engineering, I think, is being flourished, and more tunnel engineer will be requiring in future. So somewhere it was written that the strength of economic strength of a country and engineering strength of a country is also known by the tunnel they are having there, because tunnel is a very specific, very complex engineering. So if a country can have this asset of tunnel there, it means they are having a good engineering there. Now, this project we are going to discuss is in Chitral. Chitral is, if you see the map, in the extreme north of Pakistan, there is Chitral here, in extreme north. That's from Islamabad and the Peshawar, then this is the Chitral, we are going there. Just extreme border of the Afghanistan, we are having Chitral. Then from Chitral to east-north is RESHUN, where that tunnel we excavated there. Chitral is one of the beautiful districts of Khyber Pakhtunkhwa, KPK. People of Chitral are very peaceful and hardworking. Educational rate is very high, especially girls are very fond of education. This I come to know while we were excavating that tunnel. Whenever there was a breakdown due to any reason, that was a very, equipment backup was not proper, access was not proper. So we are facing the breakdown of the project many times. But whenever there was a breakdown, the girl students especially came out and they blocked the Chitral Buni road, and they demanded to start the work because they were suffering with the load shedding. Before this project in Chitral, there was only 1 megawatt powerhouse was there at Chitral, and half city was getting electricity one day, and the other half of the city was getting electricity. They were in a severe problem of load shedding. So that project, imagine our project was for 4.2 megawatt production of the electricity there, whereas 1 megawatt was there, and that even was not running in full capacity. The efficiency was only 100 kilowatt or sometimes 900 kilowatt, and that was a problem of the Chitrali people there. Land is rich of natural sources. Natural resources are there. Precious stones are there, fruit is there, tourism potential is there. Very rich district is Chitral is there. The famous for Kailash Valley, Turchmil Mountain, and then the Garam Chashma, Shandur Polo Ground is the highest polo ground of the world. These are famous tourist resort there. Oh, what happened? Yes, again, some pictorial introduction of Chitral. Kailash is beautiful there, and this polo match is there. Gliders are there. People are happy. Tirchmir. This is the title of next portion of the presentation, Tunnel for Penstock. Location of the project. Project is located at RESHUN village, about 60 kilometers from Chitral city on Chitral-Shandur road. Tunnel site is about 3 kilometers from Chitral-Shandur road. This Chitral-Shandur road is N45. If you see in the map, that is N45 of our national road network. And from that road, this Chitral tunnel, this RESHUN tunnel site is 3 kilometers from N45. Then this is a Google map from Chitral. Yes, this is again from Chitral to Shandur. Where is that pointer? Yes. Here is Chitral, ladies and gentlemen. And that is about 52 kilometers from the northeast. That is the RESHUN. This is the RESHUN. And this road is N45 road. And from here, 3 kilometers on this side, there is a site for tunnel there. Yes, this is 3 kilometers from here, 3 kilometers to this. Again, 3 kilometers. This is a RESHUN village on N45, and then this is 3 kilometers, and that is the site of tunnel. This is the inlet portal, and here is the powerhouse. And that light color is showing the route of the tunnel. It is coming from this mountain to this powerhouse. This is RESHUN tunnel. RESHUN hydropower project hierarchy is that the client department was shadow, then it changed to pedo, and now it is having a title of pedo. KPK, I mean this electric development organization. At that time, when we were excavating the tunnel, and the MD was engineer Amir Zaman, engineer Muhammad Bashir was the PD, and the RE was Nurul Bashir. And consultant and the donors were GTZ. This is a German organization, NGO here. The work of GTZ is, remarkable. They have provided the potential of hydropower in all the northern area. They are giving have compiled a beautiful data about the potential of hydropower in the northern area. Very hardworking people. I worked with them for the 3-4 years. Excellent people. Try to help out all the people there. And Michael Richel was the team leader. Dr. Kunet was geologist. All his investigation and geological report was about the RESHUN tunnel. He gave that. And Mr. Pashke and the Grossman were 2 engineers. And I worked from techno engineering, and I was in charge of that project at that time. And ladies and gentlemen, one thing is there, that this was the first tunnel ever excavated by some Pakistani engineers. Before that, Lowari Top was started in 1975 or 4. But somehow the project was abandoned for the reasons, certain reasons. And then again, that project was completed after 30 years, 2008. They completed it by a Korean company, 8-kilometer transportation tunnel. Good. Now the Chitral is having a all-weather access from Pakistan, from land from the rest of the country. Before that, 6 or 8 months, the Lowari Top was under the heavy snowfall, and people used to go through Afghanistan. And I myself went to Chitral while the project was under construction, through Afghanistan about 20 times. All our equipment and our spare parts were coming by the route of Afghanistan, from Bajor to Arandu. You know, the access to the valleys is always along the rivers, where river enters to the valley, and that is the natural access. Otherwise, we are using the passes. Passes are under snow in the extreme weather, are not providing the access to the valleys. The RESHUN hydropower project planned using the RESHUN goal. There was a RESHUN goal. They call it that is a creek. Tributary, you may say the Chitral River, that is a RESHUN tributary, that RESHUN Creek, but in the local language, they are using it RESHUN Gold. And GTZ has compiled all the data in terms of gold, Golan Gold, Shishi Gold. These are all the tributaries of the river Chitral. The intake is at an altitude of 2,340 meters above sea level. At the junction of two creeks are there, Lecture and the Shaku Gol. The water has been taken to powerhouse through inclined tunnel of 1750 meter length, housing steel penstock of 900 diameter, 0.9 meter diameter of the penstock was there. This is the inlet portal of the tunnel. And that is the Google picture again of these two goal. Shaku goal and Lecture goal is there. This is one goal. Main creek is this. And the second creek is this. And this is the powerhouse. If we will have a detailed picture of that. This is the powerhouse. And then this is the intake of the tunnel there. That red color is showing the route of the tunnel in this mountain beside. And this is the route of the RESHUN goal. The excess water is then flowing in this goal. Then again, we are using this goal for the penstock. Penstock is in this HYDROPOWER tunnel. Again, this is RESHUN goal and then penstock. Reservoir is there. And outlet, this is the penstock going into the tunnel. And the excess water of the spillway, here excess water of the reservoir is flowing into the RESHUN goal, ultimately in the Chitral River. This is again one picture of reservoir. This is also reservoir there. Reservoir. According to the preliminary seismotectonic map they consulted, the screen is not clear. Pakistan, 1975, the project area is one of the major earthquake zone of Pakistan. The rainfall, as per preliminary report of the climatology and hydrology, a mean annual regional precipitation is about 1000 mm. The general geology of the area shows a sequence of metamorphic rocks consists of shale, slates, greenstone, marble, sandstone, and also intrusion of a Tuchmil granite. There is layers of granite there in that geology. Investigation is showing the tunnel area consists of hard, massive, calcareous conglomerate, well-cemented conglomerate, self-retaining. That we were lucky enough that about 75% of the tunnel was sustainable, well-cemented conglomerate, and giving a good look inside even. The maximum length we were having, a very few length was with sandstone, where we provide the safety system, concrete safety system there. Otherwise, only shotcrete or rock bolts were enough for the safety of the tunnel there. This is a salient feature. RESHUN Chitral location is total capacity is 4.2 megawatt of this. I mean, 3 turbines are there. Pelton wheel turbines, 3 turbines. Each turbine capacity of 1.4 megawatt, and the combined production is 4.2 megawatt. Design discharge is 1.62 cubic meter per second. Net head is 320 meter. Length of power tunnel is 1.75 kilometer. turbines, 3 Pelton turbines of each 1.4 megawatt. Transmission line type 33 kilowatt transmission line is there. The length of the transmission line is 240 kilometer, and distribution line is 400 kilometer, and the total consumers are 17,000. The one thing is that this electricity is not coupled with the national grid. It is being distributed by the local arrangement, and people didn't want to give it to the national grid because they were fighting, I mean, for decades for this powerhouse. So this is being distributed at the local arrangement, not to the national grid. So about 17,000 consumers are there. Houses are having electricity from this powerhouse. Sorry. The beauty of this design, of this German design, is that with the minimum capacity of the reservoir, they are getting an excellent production of the electricity there, 4.2 megawatt. Minimum reservoir having only 5,000 cubic meter of the volume there. And when we are talking about the tunnel, we cannot go without mentioning the great man Terzaghi. His research and his finding is still helping the tunnel engineer. His guidelines are excellent. I mean, he worked, he founded beautiful research there, innovative research there, and he's mentioning each and every stress induced in the tunnel. Yeah, he's known as, the father of soil mechanics and geological engineering. Then, there are many methods for execution, for excavation of tunnels. But that, in our case, we went for the conventional method of tunneling. There are tunnel boring machine, and there are the jumbo drill machine there. Many, mechanized excavation of tunnel is there. Only at, I think, JLM project, they used this tunnel boring machine, and then jumbo drill being used for the, the tunnel of having a good surface area with heavy face is there, they are using. But for the small face, for the small area, we are using this conventional method for tunneling. There is a cyclic execution of the process, repeated steps of excavation for the relevant primary sport. The cyclic repeated steps of excavations are, there are 4 or 5 steps are there for a repeated exercise, for repeated activities for the excavation of tunneling. One is drilling, second is charging, then blasting, ventilation, mucking and hauling of the excavated material, setting out for the new blast. I'm doing the first 5, then we again set for the new blast there. Drilling pattern, there are many drilling patterns are there. Wedge cut, burn cut, pyramid cut, and fan cut. Ladies and gentlemen, this is a wedge cut. I just want to explain the wedge cut. Yes. These are the inclined holes there. Hole is going like that. This is one hole, and the other hole is like that. So it is forming the wedge here. These 3 holes in some angle, they are forming a wedge in the middle of the face of the tunnel. When these holes are horizontal, this is a horizontal wedge. When these holes are drilled in vertical direction with vertical some angle, then it is a vertical wedge is there. And then there is a combination of vertical and horizontal. One is horizontal, another is vertical. Then this cut is called pyramid. Then it forms the pyramid shape there when the wedge is on two sides, vertical and the horizontal, then forming a pyramid shape there. And that is called pyramid cut. Fan cut is having a drill pattern like fan. But most popular for the small area, that is a burn cut. This wedge cut, pyramid cut, and other cuts, drag cuts, and other cuts are for the area which is, I mean, very wide area. We are using those cuts. But for the small area, we are using the burn cut. And it is with the experience, it has proved that the heading by this pattern, by this design of drilling, that is a burn cut, give the maximum efficiency of that. These are the different drilling equipment being used for different type of tunnel. This is this is a jumbo drill machine. Sometimes it is on the track, chain driven jumbo. It is having 4 or 5 drill machines on one machine, having good, very useful equipment as far as the tunnels is concerned. And it is being used for the transportation tunnel especially. And that is a jumbo TBM, tunnel boring machine, used for this Neelam Jhelum project, 60-kilometer tunnel excavated by this machine. But this machine is having a fixed cross-sectional area that is only circular. They cannot excavate, this machine cannot excavate in U shape or in other shape, inverted U shape or any other shape, but it is excavating the tunnel in a circular diameter. And this machine is only for one machine is for one project. It cannot be reused. I don't know, Chinese have some jugaad to using it again, but it is there that this machine cannot be used again. And same machines, 2 machines were working in English Channel, one from England and one from France. They identify a stone, a lime rock beneath the sea level, and then they follow that rock. And 2 machines were excavating from simultaneously. And at the meeting point, one machine turned to the left and the other machine turned to the right, and they are still there in the limestone. No one brought them back, and it is not easy to bring them back. But that is the simplest jackhammer, pneumatic jackhammer or fuel jackhammer. This is sporting leg, and the person can easily hold that. And we adopted this technique. We use this machine for the drilling of our tunnel face. And these are the rods and the bits. Bits are removable and can be refixed, getting the new brick bits there. And this mechanism was adopted there for small face tunnel. Well, gentlemen, just one example, very interesting experience we have there during the excavation of this tunnel. Very interesting. And it is the experience to be floated to young engineers, to be floated to the, to be transferred to the blasters, and valuable and good experience. What is that? That we are having this phase after drilling. Yes, again, this is after drilling, we are having this phase. Yes. Periphery holes are there, and then the empty hole is here. This is a clear burn cut situation. This is a burn cut pattern of drilling is there. You know, the blaster charged it. He inserted the cartridge of dynamite in each hole, the design dynamite. With the experience, we were having the set design of blast there. I mean, we are having we see the rock there, what type of rock is there. And then we are, with the experience, having a maximum efficiency, we got the design there, that this is the design. So that face was charged. When this face was charged, suddenly some surveyor came and he told us that our alignment is not as per design. We are deviating our horizontal alignment. And if we did this blast, the alignment will further go, I think, 2 degrees there, we will be out there. And you should not do this blast. Then the problem is how to remove the dynamite from the hole. It was fully charged. If you see the next slide, the matter will be clear to you. Yes, these cords are there. I mean, 25 milli detonators were there. First of all, this was designed to blast the first this bun cut, then this layer, then this layer, then this layer, simultaneously with some delay time. We tried to pull back the cartridge of the dynamite. We tried it. We inserted the steel rods there and we pull it back, but the partial dynamite came out, not fully. And you know, and it is not advisable to re-drill, to drill on a charged face. Some accident can happen there. So no one was, prepared to drill on this face again. They asked us to remove first the dynamite from the face. Well, gentlemen, then our blaster, given a good idea, he electrically changed the connection of these holes, all these holes. He changed the connections, circuit, and he, changed the delay time. He changed these cords, he changed it, and they connected this to this. And then the idea was he blasted these holes first. Instead of blasting this bun cut first, you know, there is a small clip of video there that will make you understand how this is going to work there, how it is working, blasting there. And that was a very intelligent move of that blaster, that he blasted these extreme holes there. And these extreme holes were tightened, surrounded by the strong rock there. So there was no cracking, no fragmentation of these holes there. And no, the whole dynamite was burned there by this technique, and there was no advance of a single inch. No stone was split out by doing that. That way, the face was empty with the dynamite, and then we again got drilling there, and we brought it to our alignment. That we brought the alignment of the design alignment of the tunnel there. Let me check if we can see that clip there. Interesting clip. This is drilling is being done. Yeah, look, this is a technique by using a delayed detonator. He's showing it from the back side. You know how the this delayed detonator is first give the movement of the inner core, that is yes. Then there is a support system. Three main type of primary. There are primary and secondary sports are there. A secondary sport system is there. Mostly we are requiring the primary sport. Secondary sport is lining of the tunnel. I mean, steel lining, concrete lining. Seldom we require the secondary sport there, but the preliminary sports system is frequently, mostly required there. Three main type of primary sport systems are presently used in rock tunnel. They are rock bolting, steel sets, and the shotcrete. I mean, these are the famous technique to support the rock system there. Rock bolting is very important. We, just after the blast, we examine the face of the tunnel and the side of the tunnel. If there are some fear that some rocks are going to be dislodged, you know, in conglomerate, it is a well cemented, but there are fault, there are fracture line is there. So we try to fasten the front piece of rock mass to the parent rock there by doing the rock bolting. Then giving the finish level and seal the cracks there, we do the shotcrete. And sometimes we are requiring, I mean, very lengthy rock bolts just to find the parent rock there and the size of the fractured rock. We judge it, and then we design the rock bolt there, where to fasten it, where to fasten the fractured rock with the parent rock. Shotcrete is a pneumatically applied large aggregate concrete. The need of secondary lining in a tunnel supported by shotcrete depends on purpose of the tunnel. Yes, secondary support system is depending upon the nature of the tunnel. If you are going to use the tunnel for transportation, we have to do secondary system. Secondary support system is required for the tunnels being used, where the human being often pass their time in the tunnel. Maximum tunnel is being used. I mean, for those tunnel, we are requiring the secondary support system. Mostly for the other tunnels, we are only having the preliminary primary support system, that is rock bolting and the shotcrete. Then ventilation is very important. The main objective of providing ventilation system in tunnels are, these are the problems we are facing in tunnel, that to provide the working crew an environment of fresh air, to exhaust out fumes and gases that is injurious to health, explosive in nature, to remove the drilling, mucking, and blasting gases emitted there. These are the stuff. I mean, unfortunately, I couldn't get the picture of that ventilation system, but just to give one experience to you, young engineers, especially, that we installed a exhaust fan there. Then our foreman put a, 0.75 diameter, 5 feet, 1 feet, about 1 feet diameter pipe there with that fan. And he closed the fan with the sheet. He closed the fan with the sheet. Just at the mouth of fan, he closed that. And then came to me that, sir, there is no airflow in the pipe. And hydraulics engineer or fluid mechanics, they are knowing when there is a sudden contraction, we disturb the boundaries of the air fluid and the negative pressure is created there. That is the phenomena here. That was the phenomena working there. and there was no flow forward in the pipe. There was negative pressure and the air was stagnant. Although the fan was running in a full speed, then we designed a funnel just not to break the boundary lines of the airflow and to make it create a smooth flow of that is a laminar flow. And then there was excellent flow was there. It is just, I mean, a very small problem we faced there. No funny problem rather. Then mucking and hauling of that is a big problem. Drilling is a time-consuming problem and the cost-effective problem, drilling activity. Then there is a most cost-consuming and time-consuming problem is mucking of the excavated material and the hauling of the excavated material. I mean, these activities, if you clear the tunnel, then you will start the other activities. So it is very, I mean, critical activity we have to tackle with that. So initially, when we started the tunnel, we deployed the tractor trolley for mucking and hauling of the excavated material. But then after some times, after even a 100 meter, their trolley, the tractor and trolley started creating suffocation there. Diesel fumes were there and the drillers were not feeling well. So we have to, emergency, we have to leave this arrangement of tractor trolley. And then suddenly we were not planning to stop the work. So we hired the donkey labor for this purpose. And that labor was environmentally, they were okay, but they were slow. They were taking too much time to clear the tunnel face of the tunnel. Then we designed their track and trolley system there. And that was the ideally ultimate solution for this mucking and hauling. So we try trolley ourselves there, and we install the track, T-iron, inverted T-iron, 2 T-iron. We use as a, this was the track there inside the tunnel, inverted T-iron. And then this was the rope, and there was a pneumatic winch was used just to pull the empty trolleys to the face. Otherwise, filled trolleys were moving with the gravity force. No need was provided any energy to the filled trolleys. This was the pneumatic winch we were using there to pull the trolleys there. Trolleys were designed in such a way that while they were traveling on the track, they were having an angle in such, they were traveling in a horizontal direction, horizontal level. We were design body of the trolley in such a way that 12% of the slope of the tunnel was not affecting the trolleys. Typical cross section, the penstock was designed to be supported on reinforced concrete piers. This was the original design, that the penstock will come in the tunnel and it will rest on the pedestal, concrete pedestal in the tunnel. And or the second choice was to hang it with the roof of the tunnel. One design was put it on the concrete pedestal, RCC pedestal, and they were 3 meters apart, center to center. These concrete pedestals were there in the design. And the other design was just to hang this penstock with the roof. And there were about 50 million rupees were for the road from RESHUN village to reservoir. Then this idea was floated to the GTZ and the other client that let's have this penstock buried in the floor of the tunnel after excavating the trench. You know, when the tunnel was completed, then the excavation of the trench was very easy. Just open blasting. Easily they can, within months, they can excavate this tunnel, this trench for the penstock. And that idea conceived them, all the three stakeholders were agreed with this idea to have a penstock buried in the tunnel floor, and then use this tunnel as a access road to the reservoir. Then nowadays this tunnel is being used as the access road because penstock is buried in the floor of the tunnel, and this tunnel is being used as a, this is all weather access. And also the students of the school and colleges, they are coming on the weekend just to travel to the tunnel and go to the reservoir. Reservoir is a very scenic place, a very scenic view there. So they enjoy the picnic there by traveling. And in the summer, the tunnel is very cool. And in the winter, the tunnel is hot there, warm there. So it is very pleasant to ride some on jeep or some four-wheel pickup to go to that reservoir there. And our interest was only that the people will come and they will see our work there. If some penstock is hanging there or standing there, no one is coming there. That accessible, jeep accessible road was not there. So no one can judge the work which was done there. You know, now this arrangement is there, that tunnel is being used as a all-weather road to the reservoir. This is the inlet portal of the tunnel. I'm just showing how the tunnel is being used as a access road. Now this is a four-wheel pickup is going inside the tunnel, and this is the other view of the tunnel being used as a access road. There were three lateral tunnels for the ventilation and for the mucking and removing the excavated material. In the design, there were three adits were there, and at that point, it is very comfortable and pleasant. Air breeze is there near the adits. That is a tunnel alignment there from the reservoir. This is reservoir, and then tunnel is going to the powerhouse. At the near the powerhouse, the one penstock buried in the tunnel floor is bifurcated in three penstock of 0.6 diameter, 0.6 meter diameter, and they are providing the power, hydropower to the three Pelton turbines. This is again portal, and this is a powerhouse there inside. This is a powerhouse building, and this is a tunnel portal. Inside tunnel is this is a view of powerhouse. Three Pelton wheel turbines giving 1.4 megawatt each turbine. One is this, other is this, and the third is this, giving excellent performance and good production of electricity to the locals. Again, this is a reservoir, and this is a reservoir, and this is powerhouse. Yes, that was the last blast. There is a video, but I'm just producing the still pics there. Gentlemen, this was surveyor told us that here the outer portal will be, outlet portal will come here. But unfortunately, we encountered a gorge just before this outlet portal, about 300 meters downward. Suddenly, we encountered some gorge there, and Terzaghi warned about that gorges in the tunnel many times, and many tunnels face this problem, and sometimes the tunnels were choked and created difficulty created to clear that. Even it took 2 years to clear the gorge debris from the tunnel in Lebanon and in other countries. We also encountered a small gorge there, and there was a sand flood and debris and stones there. Tunnel was filled with that, and we tried to remove that debris, but it was time taken, and it was more debris were coming there. We were not successful getting it removed. So we decided to divert the tunnel at that point, and penstock is now through the gorge area, but the tunnel is diverted there. Previously, this was the outlet portal for the tunnel, but due to that gorge, the tunnel portal, the blast came here. It is only, even then, it is only 5-6 meters away from our design line there. Of course, after that, we make it a proper shape. We gave the proper shape to the inlet portal, and no problem was there. No problem created by that gorge appearance in the tunnel. Gentlemen, this is yes, this is initial blast now. When we capture just first instant, the last blast of the tunnel. And this is again last blast of the tunnel. Yes, this is fully blasted. The last hole was there, and tunnel was completed. Excavation was completed there successfully, and the people were celebrating this opening of the tunnel. This was the outer portal there, and here I am sitting. If you recognize me, at that time I was quite young. And here is the outer portal there. Now, a few recommendations. This is the end of my lecture there. Few recommendations, gentlemen. You know, the importance of tunnel making has been brought into sharp focus in the context of Pakistan. Really, this field is flourishing fastly. 25 kilometers of length of tunnel excavated by NHA, and 60 kilometers about that that is a JLM idle project. That is 65 kilometer tunnel there. You know, those tunnels are the water tunnel. Still, there are tunnels under construction. Few hydropowers are under construction in the vicinity of Chitral. That is a Golden Goal, having a 8 kilometer tunnel, but that is a water tunnel, flowing water in the gravity flow tunnel is there. Then there is a Drosh powerhouse. It is also having a 5 kilometer tunnel, U-shaped tunnel, inverted U. That is also water tunnel with water is flowing gravity. This RESHUN tunnel was only for penstock tunnel. No water is not designed to have water inflow in the inside the tunnel. So the requirement of water tunnel and the requirement of transportation tunnel and the requirement of the utility tunnels are entirely different. And measures are depending upon the nature of the use of the tunnel. So this field is very important in Pakistan nowadays. Hydropower projects used for the hydropower project, used for the transportation project. There is a need of formal training and on-job training of the engineers in this field. You know, engineers and geologists should get some training for this field. surveyors very important for tunneling to have the alignment and all levels to be observed there, how the tunnel surveyor, then the drillers. We were lucky enough that we got the drillers, the people who worked for the Bela Dam. They all team of Chitrali people, they worked drilling at the Bela Dam. So they were very skillful people and they gave very good progress they were giving. Sometime we were doing the blast 3 times a day, and for every blast we were getting the advance of 1 meter. So it took 3 years to complete that tunnel there. Then blasters, this is it's a very specialized job. There should be a good training for that. We're a key person in tunneling. The blasters are the key person. Then permits to be issued to tunneling to explosive people. There is only one in Pakistan. There is only one explosive inspector at Pakistan level. He is sitting at Karachi and controlling all the country there. How he can control the country by sitting there in Pakistan? That is, I think, some political seat is there. They are not doing any serious work there. So some authority should be established to control this blasting and tunneling. This is a very sensitive engineering discipline. So some check should be there. Recently, FWO has established Pakistan Tunnel Institute, Pakistan Institute of Tunneling. Beautiful building is there at Islamabad, but they are not, doing any knowledge spreading activities, some training to the student, to the engineers. I myself haven't seen any seminar or any library they are having there. Only a grand building and beautiful cars there. Grant of permits for blasting. Yes, there should be some regular special people there for blasting, and permit should be issued to them. Development of standards, underground excavation. There is a dire need for developing the local standards for underground excavation and tunneling. There is a European standards. They have listed 10 sections, their handbook, European standards of excavation. They give a standard of each and everything. You name about tunnel, about explosive, how to store the explosive, how to waste the explosive when you are not requiring. What are the measures to destroy that explosive? You cannot leave that explosive there. You have to destroy the explosive by the books. So each and everything is there, how to drill there, how to charge the hole, how to do the ventilation, what is the requirement, what the safety measures should be there. These are given in the European Standard Code book, how to the practice of the good tunneling. About 20 sections are there, and those sections are attending each and every aspect of the tunneling. Well, gentlemen, thank you very much for your kind patience, and I try to share my experience there. Daisa, this is all today's lecture.
Okay, thank you very much, Dr. Riaz, for explaining how the work on the tunneling goes on, and what are the major factors which one should consider while doing the tunneling work. So now we have few questions. I will request the participants that now the number of questions I have already, I won't have the time to allow any question on the microphone. So I will be reading these questions, and Dr. Saab will try to answer them. And in case the question is not understood by Dr. Saab, then I will give the chance to the gentleman who has raised the question to explain what he is asking. So most of the questions are from Yes,
If
Dr.
it
Sahab.
is time constraint, they make send me by email or by WhatsApp even for any query there.
Yes, I have already shortlisted the questions. A lot of questions, but I will try to minimize because we are also short of time. It's already 3:42. So any lecture which is above 90 minutes, we have difficulty in uploading it on YouTube. Anyhow, the first question is, will the charging scheme for buffer and the main blast remain the same? Dr. Saab.
Yes. Yes, in my view, buffer charging and the main blast, it is same. I mean, we are having the same charging, same drilling. The matter is only to check for the flying rocks there, how to flying rocks. Blasters are so experienced, listed with the one over, they can even tell you how this boulder will split there by the blasting. They are so expert. You tell what size you are requiring the breakage there. They will design the charge in such a way that the same will go there.
Okay, ji, thank you very much. Now, second is, it is not a question, it is a comment made by Mr. Furqan. And I'll just read the comment, his observation. And if you want to dilate on it, Dr. Saab, you can. He's saying, I want to add a comment that difference between pre-split and smooth blasting is that pre-split blasting, we blast the pre-splitted line before main production blast. And in smooth blasting, the line drilled nearest to excavation line is blasted at last with very light charging. So this is only a comment. So if you want to add anything.
You're right. Yes, he's right.
So you agree with this comment?
Yes.
Okay. Now then we have a question from Suhail Kibriya. It is just a query. He's saying, while showing Google map of the project, you mentioned the powerhouse just close to the intake structure of penstock. To my understanding, the powerhouse should be located at the far end of the penstock. Can you kindly clarify?
Yes, it is about 500 meters away from the penstock outlet. Then the penstock is bifurcated in three portions, three pipes. And from that, from the outlet portal to the turbines, those three pipes are entering in the powerhouse. Embedded, they are also embedded, and they supply the water to each Pelton wheel turbine there.
Okay, thank you. Now we have next question is from Mr. Furqan. He is again, I think it's a comment. He's saying TBM cannot be used, but its back system can be used for other TBMs. So can you?
Yes, of course, some part, I mean that portion carrying the excavated material and disposing it off, we can, maybe we can use, it is not my experience. I am not having any, I mean, experience about the TBM. This is what we read and what we heard from the engineers.
Okay, thank you. So now again, the next question is from Mr. Furqan. He is asking how the powder factor for rock mass excavation was set. The powder factor.
Which one?
He's asking how the powder factor for rock mass excavation was set.
By flushing the, we are keeping on water flowing in the drill there and flushing to check this powder factor there. We are flushing, keep on flushing the drill hole there. The mechanism is there.
Okay. Okay. Then the next question is regarding, I think, the movie that you showed for the holes that were blasted. So this question is regarding that. He's asking that if the perimeter holes were blasted first, then the cracks would have gone beyond design line And what delay system was used?
You know, they were, I mean, in the movie, it is shown that how the one cut, we blast with the delay system of 25 milli detonators were used there. And with that interval of time, it gives the jolting and the cracking to the inner side. And then outer is moved at the same after the delay of 25 millisecond. And then the outer one, you know, they are all coming inside. All the excavation is coming inside. If the periphery holes are being blasted first, of course, there will be some cracking, some will be there, but no breakage of the rock is observed because those holes are so much tightened in the rock there, having no movement, no free surface there. But in the case of burn cut, we are having a one empty hole providing the free surface to the other holes. You know, there is some movement shock wave creating the cracks, then gas is produced and gas is filling that cracks and expanding there and causing the breakage of the rock there, rock mass.
Okay. Now the next question is from Sohail, and I think it was in the next one, Furqan Saab tried to answer that question. So Sohail Kibriya asked, Sohail Kibriya's question was not the pre-splitting technique used also? And to which Mr. I think Furqan replied, for tunneling, smooth blasting technique is used, I guess. So if you have to answer, please.
Yes, we are not using their pre-splitting or smoothing or cushion blasting. Main blasting is there done in the tunnel by using the delay, detonators, electric detonators, delay detonators, and it is the design of the charging pattern of the blast. We minimize the overbreaking there. The idea is, the objective is to keep us to the design phase there. So with the time, with the 2, 3, 4, 5 blasts, we come to an optimum design of the charging there to minimize the overbreak and to underbreaking also by a set amount of the dynamite explosive, using that explosive there.
Furqan Saab has made another comment. So if you have anything to add there, you can. Otherwise, I will just read out the comment. It's for such rock conditions, hybrid support system is beneficial with shotcrete plus wire mesh and then rock bolting.
You know, first we are doing, yes, you are right, we are having a combination of this preliminary support system. First we do the rock bolting, then some wire mesh with those rocks nuts there, rock bolt nuts, and on that wire mesh we are doing the shotcrete, and that is a sound arrangement there, that net also providing the strength to hold the shotcrete there.
Okay. And the next question again we have from Furqan Saab. He's either it's a comment or a question. I didn't read it. Okay, I'll read it. For ventilation fan is put outside at portal and ventilation duct is brought inside the tunnel around 25 meters behind face, and then from outside and fumes go out of tunnel through tunnel space. So have you understood the question, Dr. Saab?
Yes, maybe this mechanism also good, but this is also workable, that near leaving the space of the drilling crew there, we are installing the fan there, and it gives the comfortable environment to the driller there. 2, 3, 5 people are working there. No dust is there, nothing is there. Fresh air is flowing and the dust and gaseous air is going out. That mostly the pipe duct is coming out from the portal. Fan is inside.
Okay, the last question I have is, sorry, it is not the last question, but the third question, but this is again from Furqan Saab. He is asking how much delay was used in tunnel, sir. I don't know.
I told you in our case, we use 25 milli detonators delay, electric detonators. That is 1/40th of the second. The delay was 1/40th of the second. There are half-second delay detonators are also available, and our detonation was 25 milli delay electric detonators.
Okay, now next is just the information given by Mr. Furqan. He is writing that British Standard 5607 is used as guideline for how to handle explosives. So this is just the information.
Yes.
And now we have a question from Suhail Raza. He's asking, in the absence of any national standards for blasting underground excavation, did you use European standard at RESHUN tunnel?
No, GTZ people gave us the German standards. It was written in the agreement even that we will work according to the German standards. There were, tunneling, explosive, all they were having a standards. There we use that.
Last question is from Mr. Rizwan Mirza, and he is asking why there was no mention of uniting and grouting. Were they not required anywhere?
No, I skipped that. Lighting, of course, without lighting, this is also a standard there. According to the standard, every driller should have a light on the lamp cap there, and inside there was lighting system, and we did the shotcrete rock bolting, but sorry, I skipped that activity. I didn't show that there, but that was there. The preliminary support system was adequately executed there.
No, Dr. Saab, I think I did not read the question properly. You can. He's asking about uniting, G-U-N-I-T-I-N-G, uniting and grouting.
No, especially grouting was not experienced there in our case. No grouting was there. Grouting, simply rock bolt was there, no grouting beside the rock bolts. Just shotcrete was there, fastening the chicken net, and this. Inside the rock bolt hole, there was no grouting executed there.
Okay, we are now almost finished with it, but Rizwan, if you want to say something, please come on the microphone, and on this issue of grouting, if you want to say something, please. You can utilize 3-4 minutes. Please go ahead.
I don't really know what type of rock they had, and I'm not an expert in geology. But since Dr. Riaz has worked there, I am supposing and assuming that it must be good rock and not profusely fractured. That's why their bolting worked. Is that a correct understanding, Dr. Riaz?
Yes, sir, you are very right. You know, I before the presentation, I told that the 75%, more than that, there was a well-cemented conglomerate. But wherever some sandstone or some metamorphic rocks are there, some cracks or some fracture was observed, and that portion was well rock bolted there. I mean, those hanging portion, when we observe there some crack there, or maybe some horizontal crack, and then there is a crack behind that portion, behind that rock mass is also there. So we are drilling through those two cracks to the fasten it to the mother rock behind it. There were cracks there, observing that. Mostly the tunnel geology was well cemented conglomerate. It was not showing any crack and self-sustaining the shape of the tunnel.
Thanks. This answers my question. Thank you.
Thank you, sir.
Okay, thank you, Dr. Saab, for the lecture and answering all the questions which we had. So, gentlemen, with this, we come to the end of this lecture. Dr. Saab, your shield and your certificate, inshallah, would be delivered to you by DHL, by Ms. Sadia Naveed. And gentlemen, for your certificates, you can collect the certificate from 15th of March from 83M Model Town Extension, Lahore, the same office which we are using recently. And the phone number is 0345-424-3404. I will repeat the address and telephone again. It is 83M Model Town Extension. And the... Huh? Okay, and we have the next lecture is on 16th April 22, and the topic is beneficial use of coal combustion residues in sustainable infrastructure rehabilitation. The speaker is Dr. Tarunjeet Singh Butiala. He's a associate professor in Ohio State University, USA. Now, we cannot announce the time of the lecture at this time because there's a huge time difference between Ohio and Pakistan, USA and Pakistan. So we are trying to manage a time which is convenient to Dr. Singh and to our participants here. So I think that this issue will be resolved soon, and Ms. Sadia will make the announcement, I think within 10 or 15 days, within 2 weeks, she will make this announcement. So please remember the lecture is on 16th April 2022. The topic is beneficial use of coal combustion residues in sustainable infrastructure rehabilitation. So this is what we what was the lecture today. Now we have come to the end, and still, if you have any, I just got a message. Still, if you have any questions on today's lecture, you can email them to on PSCE's mail address, which is psce@psce.org.pk, and you know, okay. psce@psce.org.pk, and those questions will be forwarded to Dr. Riaz Akhtar, and he would be very happy to answer those questions. Regarding the collection of the certificates, I have already announced it is from 15th March, 83M Model Town Extension, Lahore. The old number is not now in use. Kindly note down these three numbers, which you can, before coming to the office for collecting the certificates, you can call on these numbers to confirm for the collection. Please note down, these are landlines. It is 042-3516-8052. I repeat, 042 is the Lahore code, then 3516-8052, and we have two lines. Total are three lines. So 3516-8052, 53 and 54. So before coming for collecting the certificates, you can call, if you want, you can call on this line. Anyhow, certificates will be available from 15th March 2022. Thank you very much, gentlemen, for attending this session today. And I will request all of you to support PSCE in any way you want by giving your input for our magazine, for our journal, or helping PSC to make more associates, student associates and associates. That will increase our membership and will make our organization grow further and further. Thank you very much. Allah bless you all.